ionic and covalent compounds in my daily life? Well, since my teacher asked us to do this question, I think it's time to do a quick educational video about it. So strap right on in and let's learn about ionic and covalent bonding. Yay! Okay, so ionic or ions is basically the bonding of a positively charged ion to a negatively charged ion. Or to put it in simple terms, bonding metal to nonmetals. You see, the first element right here on the right is the metal, positively charged ion, while the left element is the nonmetal, negatively charged ion. Metals are located at the right side of the periodic table of that staircase that you see right there. The nonmetals are located at the left of the staircase. Electrons are used to create these compounds because the more electrons an atom possesses, the more it's an anion of number of electrons. While losing electrons becomes a cation, loss of electrons, and more protons. The number of electrons used to format the compound has to be no bigger or less than 8. You see, if you don't have 8 electrons in your atom, then it becomes unbalanced, causing problems for the two elements to bond together. You only need 2 atoms to create a compound, no more than less, okay? The first element, or the metal, is named normally. One example is sodium. Then the second element, or nonmetal, gets its ending changed to the suffix "ide." And then we change the ending of chlorine to chloride. Put those together, we get sodium chloride. There, simply we did it. Here's your reward. So in conclusion, ionic compounds are compounds that gain or lose electrons, anions and cations, while covalent compounds are nonmetals plus nonmetals. But covalent compounds don't give electrons to the brethren, they just share it. They need to share a total of 8 electrons for it to work, but covalent bonds are weaker than the ionic counterparts. One example of naming covalent bonds is by using Latin prefixes. Let's say we have phosphorus and fluorine. That is used 3 times to get 8 valence electrons for phosphorus. Phosphorus would just be phosphorus, and fluorine would just be trifluoride, because tri represents 3. Together, we get phosphorus trifluoride as our covalent bond in wording. Now I have to explain the examples of some ionic and covalent bonds in everyday life for me. Well, one example is table salt, which is sodium chloride, an ionic compound. Second is bleach, which is sodium, oxygen, chlorine, also known as an ionic compound. One I use every day when I get up in the morning and brush my teeth is some good old sodium fluoride, which is known as toothpaste. Sodium, oxygen, hydrogen, or sodium hydroxide is used for cleaning drains, and K2HPO4 dipotassium phosphate, plant fertilizer, are both ionic compounds. Covalent bonds in my home, we got LPG, which is liquefied petroleum gas. It is used for cooking, scenarios like heating up the stove. It's compressed with a mixture of propane, C3H8, and butane, C4H10. More hydrocarbon gases are mixed into it as well. Vinegar is covalent and is chlorine 3 carbon oxygen hydrogen, or known as acetic acid. Plastic is C2H4 dicarbon pentahydride, and water is known as H2O dihydrogen oxide, and oxygen is just oxygen. I think I should just bring in a bottle of oxygen to school to showcase that I have oxygen. What is this? It's oxygen, but in a bottle. Sahib, you graduated. So I hope you enjoyed my video project for school, and I hope you learned something about compounds. I wonder what my classmates think about this video. Hey guys, what do you think of this video? Alright, I see. Anyways, thanks for watching, and I hope you enjoyed this video. Now, I got a jet. Bye-bye.